dictates what? Yeah, understand what they tell you. Position which you weld. One is what? All position, or what they call out of position. And two is flat and horizontal only. What can be the reason for two? Why they put a two in there? Why you can weld only in flat and horizontal position?
Because the flux will get included in the weld.
Typically these struts have a lot of flux, right? And because of that, and because you have a lot of flux, obviously you have to crank up the amperage, which makes the paddle very fluid and will not be sustainable in vertical up and overhead. Okay? It'll be a question on dissipation of heat between the base metal and the rod in any polarity. Actually, it will be just one of them. Let's take, for example, DC reverse polarity. What is DC reverse polarity?
The electrons are going from the work to the electrode.
So we call it reverse because electrons flow against of your hand. If you go through your hand, that will be straight polarity, right? And what is the dissipation in all the polarities? AC, we know it's half and half. Reason being, you go through alternation, right? Half of the time positive cycle, half negative cycle. So it's half and half. If you have a DC plus polarity, or what you call reverse polarity, electrons flow against of your hand. Where you expect to have the most heat? On your hand or on the base metal?
If it's straight polarity?
No, reverse.
Reverse polarity. So most of the heat is on the electrode.
Yeah, because you all the time you associate the most heat with the direction in which electrons flows. If it flows against of your hand, this means your hand will actually have twice, 2/3 of the heat, and the base metal will be one third. There will be a question on different type of radiations. Which one is the most dangerous one? You have light, ultra, UV radiation. Do you feel UV radiation? No, you feel it later, right? In relation to that, we have different types of burns, first, second, and third degree burn. You have to know about that. Another question will be on maximum working pressure, maximum safety working pressure when you use an oxyacetylene cylinder, oxyacetylene system, I mean. And choices: 10 psi, 5 psi, 15 psi, 40 psi. What is a safe pressure to work with when you relate to acetylene? 15 psi. What can be that? Why can be that? Even if you have the mark from what? From 0 to 2D, right? On the gauge, but right in the middle, you start with a red zone and ends up with 2D, right? And the reason for that is?
Well, anything above 15 psi in the acetylene is unstable.
Destabilize. Thank you, sir. Destabilize the gas. Gas doesn't like to be pressurized quick, won't depressurize very quick.
But if 15 is the maximum pressure, then 5 would be the safe pressure, right? You want to give yourself.
Well, it depends on what kind of orifice you have on the. Sometimes you have to go close to 15 because it's a big, whatever orifice. So it accommodates whatever kind, but no, it's safe to don't go over 15. And remember, that's very important. When you open up the cylinder, you have to be sure all the time your barrel is closed, right? Makes sense to you? First, to start with, and you have to have your knob relax, go all the way out, right? Not all the way out. I mean, you don't feel any pressure on the gauges. So in this, I don't have the surprise to get over 15. Okay. Okay. Why oil and petroleum product never should come in contact with oxyacetylene equipment? Choices: contaminate the gases, clog small internal orifices in the system, create danger for explosion, produce weld porosity. So why petroleum products and oil? Oil and petroleum products. They shouldn't come in contact with oxyacetylene equipment. So you have two of the most dangerous gases in the shop. One of them is acetylene, and the second one is oxygen, right? Oxygen. What is so special about oxygen? When they come in contact, when it's coming in contact with petroleum products, it initiates a very quick expansion of the gas, and that is pretty much a definition of explosion. So the choice for you will be explosion, right? Got it? So that means what? Your gloves, you don't supposed to have gloves when you put this in place. Watch your hands. Good idea to blow the bottle before you put the, you want just to be sure. Now you have to fill up a blank in here, and choice will be volts, amps, ohms, or watts. Filling the blank is a unit which measures electrical pressure. Huh? Who said that? Man, you're good. Volts, yeah. What about watts? What you measure in watts?
Volts and amps.
Huh?
Volts and amps.
Volts?
Power, right?
Power, yeah. What about ohms? Ohms, unit for what? Mr. Ohm is standing in his grave now. Huh?
Resistance.
Resistance, yeah. Electrical resistance. And amps? Amps? The value of amps is number of electrons per second moving through a conductor. Okay? And that is the definition for current. Okay? We work with a constant current type of power supply, right? When you talk about stick, not about flux core. The unit measures okay. What unit measures the position of electron flow through a conductor when you have a difference of potential at the ends of the conductor and an electromotive force present? It's a long question, but one more time. What is a unit measuring the opposition through the electron flow through a conductor when you have a difference of potential and electromotive force present?
Well, that's the resistance. That's the resistance.
So, current to flow, you have to have two conditions. You have three conditions. You have to have conductor, difference of potential, and what else? Electromotive flow. So you want to ensure you have electrons flowing through, right? And what force opposes the movement of electrons through a conductor? All conductor conduct the same? No. Why? They have different resistance, right? So it's actually electrical resistance, and the unit for that is ohms. That was your choice. Got it? You didn't get it, right? Did you? Everybody got it? Bummer. Constant current type of power supplies, right? Remember we talked about them, they have a very high internal resistance, and to be able to strike an arc, you have to have what? And what, how do you call that? Open circuit voltage, right? Remember that? So we have open circuit voltage, constant current, and operational voltage with constant voltage or constant potential. same animal, different hair. I have in here certain values, 80 amps, 90 volts, 80 volts, 100 volts, and the question is, what is the value of the voltage between the electrode and the base metal with the machine turned on without striking arc? 80 for the whole machine, 90 for the fee. Choose one of them, it's fine with me. Usually it's 80 volts. You will not get even 80, even the machine tells you 90. The new machine is supposed to have calibrated 90 volts. Pay attention to that because we have another 80 in there, and that's have an A after that, and that means amps. For some reason, for 20 years, people choose 80 amps rather than 80 volts. I don't understand why. Maybe because A is before V. I don't know. What Ohm's law reveals to you? Electromotive force and electric flow are direct proportional. Electron flow and resistance are direct proportional. Resistance and electron flow are inverse proportional. Electron force and resistance direct proportional. Power is a product of current and voltage. Okay, so can you imagine Ohm's law? What Ohm's law tells you? Three items have certain relationship between themselves, right? Volts relates to current and resistance direct proportional. And if you have this in mind, you choose the proper ones. You have more than one choice in here. Okay? And current and resistance, they're inverse proportional. So look at this. Electron force and electron flow are direct proportional. Yes. Electron flow and resistance are direct proportional. No. They are inverse proportional. Resistance and electron flow are inverse proportional. Yes, sir. And the last one, electron flow and resistance are direct proportional. Yes. And the other one is true, but have nothing to do with the question. Power is a product of current and voltage. Okay, makes sense to you? We have no relation to Ohm's law. Makes sense?
Well, the question is which one of these things is
true? Yeah. Mm-hmm.
But several of them are true.
The other one is true too, but no relation to Ohm's law. And the question is referring to Ohm's law. You guys get this? You go to Used by Mud, and they ask you a question in some test in there, and they want to figure out if your brain is sharp enough to realize if the question relates to the answer relates to that one or not, right? They do a lot of that. That's critical thinking, right? That makes sense to you? So you have to be all the time on you. You see, I'm telling you Ohm's law, but I'm not telling you Ohm's law formula. What I'm telling you, what Ohm's law is. The proper answer is a relationship between three items. That's it. That's the true answer, right? And if somebody throw in my face this when I'm asking a question, I know the guy, his brain is working fine. Rather than to have him writing down formula. Make sense to you guys? So get acquainted with the details because that's important in life. 10. What device takes a relatively high voltage, relatively low amperage, and changes the low voltage, high amperage through the device? Bridge rectifier, step-up transformer, step-down transformer. We talk about that.
What was it?
The question is, what kind of device take a high voltage, low amps, and pretty much flip it? First of all, have to be a transformer, right? Mr. Tesla it's a transformer. What kind of transformer does that? Step up or step down? Step down transformer. Okay, step down transformer. Recommended percentage of the time out of 10 minutes that the welding power supply can be used continuously is recognized as reaction time, duty cycle, operational time, optimal time. Huh? Duty cycle. How do you measure duty cycle? Maximum settage. Maximum settage. And it's increments of 20. 20, 40, 60, and so on and so forth. What is the proper application for considering the type of the welding machine? CC is used for automatic or semi-automatic application. It's not true. It's only for what? Manual processes, so that's not true. Constant potential is used for manual and also semi-automatic processes. This is true or false? What means constant potential? Means constant voltage. Do you use that one for manual and semi-automatic? No. Constant current is used only for manual application. That's true. Constant voltage using for semi-automatic and automatic applications. True. So you have two truths in there, right? Shielded metal arc welding process use constant current type of power supply machines. True or false? Miguel, don't look at me. Come on, give Papa an answer. Shielded metal arc welding. What that is? Shielded metal arc welding. What that is?
Welding.
You guys lost your way, or?
I know I have to go get some stuff.
We're almost finished. Okay. Shielded metal arc welding. That's another name for what? Stick it to the man. Come on. Stick welding, right? Okay. What kind of power supply you use? Constant current? Constant current, so it's true. Flux core arc welding process. I'm sorry? Al Capone, what you saying? Okay. So, flux core arc welding process use a constant voltage type of power supply. True or false? It's true because of what? It's a wire feeder. You have to have a constant of the volts. An electron has a discoloration in the end more than a quarter of inch after the weld indicates what? Arc too short, rod angle too steep, amperage too high, voltage too low, oxygen contamination. Huh?
Oxygen contamination. It could be a few of them.
It will be oxygen contamination if you're talking about TIG process. But if you talk about this class is flux core and me, I mean it's stick welding and flux core. You deal with a rod now. So if you have a discoloration at the end of the rod, more than a quarter of inch, what this tells you? Arc too short, rod angle too steep, amperage too high, voltage too low. Amperage too high, settage is too high. And you burn the flux before you use it. Okay, so the rate of burning of the rod, the flux is supposed to be the same rate to which you melt the wire. And that is dictated by that quarter of inch, pretty much. So even if you don't know the machine, right, you might put your hand on the machine which actually you don't know how it works. It might tell you one thing and actually it'll tell you something else. Okay, you have long cables, you have connected to the same grid, the same system, maybe 50 machines, and they work at the same time. You don't get the same, even if you set the machine for the same. Make sense to you guys? Okay. So you got that one. What is an arc blow? Arc blow.
It's like magnetic interference with the earth.
Yeah. It's a ballast or a residual magnetism from a different source which interferes with what? The magnetism of the rod. So magnetic interference with the electromagnetic field, that's what it is. Okay? And it can be attraction or rejection. If it's the same sign, north-north, reject, or south-south, and if it's north-south, they bring in different directions. So. And that goes hand in hand with the amount of current going through a conductor. Remember Ohm's law? Current flowing this way, magnetic field perpendicular. If a bigger number of electrons flow through, the magnetic field is stronger. So you tend to have a lot of arc blow on use high currents. Okay. Machine slope. Remember what machine slope is? The graphic, right? What items we have on it? Remember what items we have on that graphic? Volts and amps. And if you have volts and amps, you can identify what? The question is what welding machine slope identifies? Power, voltage, or resistance? If you have volts and amps, you can calculate based on Ohm's law resistance of the machine, right? So you can actually figure out what is the resistance of the machine. And remember, we talk about constant current type of power supply have a very high internal resistance, constant voltage very low. That's why we need the open circuit voltage with constant current, because otherwise you cannot strike an arc. Got it? Okay. Machine slope, that's a follow-up question pretty much. A machine slope, the slope of the machine, it's identified by volts, power, electron force, electromotive force and amperage, resistance and amperage, induction and voltage. So it's pretty much electromotive force and amperage. So you have the two items. Correct size of the welding joint, why it's in there? To make the weld rigid or to ensure flexibility of the weld, therefore preventing cracking in heat affected area.
Ensure flexibility.
What means joint, proper joint, welding joint? Let's think about it. If you have a plate, right? And rather than to have a 45 to 60, which is the recommendation of the Welding Society, to ensure full penetration and full fusion, right? You reduce this one to 30. Okay? Now you do the welds, and you try to bend and it snaps on you. Okay? There is a good reason, engineering reason, why the joint have to be a certain size, or you have to have a certain angle, or to have a preparation of the groove to a certain depth. Okay, all of them go hand in hand. And in top of it, you might have a weld which have a big cap that put more stress in heat affected area. Make sense to guys? Got it? Okay. So all of this, anytime your weld have to be as strong as the base metal. Usually it's not. Why? Because you're dealing here with thermal, whatever, spaces in there. Liquid one time, right, in the center. Dissipation of heat, formation of different type of grains, okay? That grains can go bigger or smaller based on whatever carbon you have on it or rate of cooling, makes sense? How much heat we have in the plate. So all of this now create problems. So all these problems doesn't happen in the weld. It's happening next to the weld in heat affected area. And this is accentuated by the improper joint preparation. Okay? So you want to have this proper joining or proper joint for what? To ensure flexibility of the weld in case now. You have 5 forces acting against your weld, remember? Tensile stress, compression, torsion, bending, and shearing. So all of them, you have to ensure the weld is flexible enough to keep up with this, right? You bend it, it's supposed to bend it the same way like the base metal. If snaps, obviously you have a problem with that. Okay, low current setting can result in So low current settage can result in poor fusion, incomplete flux reaction, poor arc stability, slug inclusion, all of the above, none of the above. All of the above. Okay. High current settage can result in poor arc stability, high weld bed contour, excessive sputter. It can be first and last one. Because what's happening, you have a very high settage, you burn the flux before you use it. You don't have the benefits of that, and that you have obviously have excessive sputter. High weld bed contour. No, not being that. The percentage of carbon in cast iron is choices between 0.2 to 1.7, B 2 to 2.7. Another choice is 1.7 with 4.6, or 0.95 to 3.5. So 1.7 to 4.7. Cast iron. You have an extra in the extra carbon point, but that's for precipitation carbides. It's different animal altogether. You have what? Iron carbide, chromium, and tungsten carbides, in case you do some TIG, which is not part of this class. Still, heat affected area zone is depending on rate of cooling, carbon percentage, high size of the metal, base metal, none of the above, all of the above. All of the above. So rate of cooling have something to do with the heat affected area getting bigger. Carbon percentage, same. Size of the metal. Why? Because the dissipation of the heat in the plate is different on different thicknesses of the material. All metals and their alloy are allotropic. Remember we talked about allotropic transformation? Okay, what is allotropic transformation?
The ability of metal to change its crystalline structure at different temperatures.
Okay. All of them are? No. A handful only. Hydrogen and nitrogen improve steel ultimate strength. False. What nitrogen and hydrogen does? Produce embrittleness. So anytime when you have encapsulation of the gases, porosity, you question if you don't have already cracks in the base metal. Not base metal, usually happening outside of the pool, or in the pool too. One primary advantage of flux core process is use an inexpensive constant current voltage power supply. It's constant voltage. Use only for ferrous alloys. That's a disadvantage, it's not an advantage. It's true, but it's a disadvantage. Wire, it's inexpensive. No, it's the most expensive, so not a choice. High quality, high deposit rate process. True. Require less edge preparation. True. You have a higher fluidity, you can get away with about half of the preparation of the groove. If, for example, for the same plates and same position, same size plate, same position, you require 45 degree, you can get away with 25 with this, because it's so fluid. Got it? High rate of metal deposit, that's another one. Okay. Before I tell you the last one in here, I have to go to the same principle which I had if you took my course before. You're having here a list with items, and you have to identify what you have on the welding symbol. And if you remember, I give you from chapter 21 last time, certain stuff which you have to keep in mind, and it'll be one drawing from one welding symbol from there. Sound good? Okay. Question about it? Thank you. That was the last point in here. Let me see. Let me read it right. I don't want to do a mistake here. Thank you for investing time in this welding course. Have a nice vacation. Okay. So, did you guys learn something in this course or no? Okay. There is a lot of stuff to grab. Thank you for your time.
Shut up, I'll